So, as always, I'd like to start by saying thank you, everyone, for coming. My name is Cody Armstrong, and we are talking about the basics of sketching today. So, let's jump into it. Now, what I'd like to do is get into, what are the fundamentals of sketching in Onshape. And as I always say with these webinars, I really encourage you to ask any questions that you have. So feel free to type in any questions in the questions dialog. I'll do my best to stop from time to time and answer any questions that you have. But again, you know, um, as we're going through this, feel free to question. There's a questions dialog, and you go to webinar panel. Feel free to type anything in. All right, so let's jump into it. Now, before I get into the topic of the day, there are a few things I like to cover about Onshape in general. So for those new users out there, the first thing I always like to mention is Onshape's mission statement. That is getting everyone working together with CAD on any device, anywhere you are. And this means mobile devices, including iOS, so iPads, iPhones, Android tablets, Android phones. And these are full functioning, mobile apps. And also means Windows, Mac, Linux, Chromebooks. It doesn't matter what kind of computer you're in front of, you have accessibility to your CAD data. So getting everyone working together anywhere you happen to be is a big part of our mission with Onshape. Now, the other thing I like to mention is we do consider ourselves professional 3D CAD. And so when you think of professional 3D CAD, there's really three pieces to it. There's parts, assemblies, and generally drawings. We do have all three major pieces that make up a professional 3D CAD system. What's unique about Onshape is you're going to see as you use it is it evolves very quickly. New functionality is added roughly every 3 weeks. There's nothing at all for the end user to do. You just see new buttons pop up, new functionality appear. So you're going to see Onshape evolve very rapidly. The other things I always like to mention is with Onshape version controls built in, a lot of traditional CAD systems, these are managed by PDM systems or something to that effect. None of that's really necessary in Onshape, but the version control, because the version control is built into the core of functionality of the software. So the other thing I always like to mention, if you have a library of CAD data or if you've come from another traditional CAD system, we can read and write a lot of the common CAD formats that are out there today. So STEP, IGES, Parasolid, a lot of those formats that people are used to importing and exporting, we can also import and export. So it makes Onshape a great tool to work alongside an existing CAD system, maybe share with vendors, those kinds of things. The last thing I want to mention is with Onshape, we've introduced entirely new methods of collaboration. So real-time collaboration between users, very similar to Google Docs. The ability to, with follow mode, see each other's screen in real time or add comments to a document. All of this is really adding a whole other layer of collaboration that's never really been in CAD before. So these are always the things I like to highlight, especially important if you're just getting into Onshape, just some important points to mention. So what are we going to talk about today? Well, as I mentioned before, this is really an introduction to sketching. So I'm going to walk you through kind of the basics. The assumption here is you're just getting started and you're trying to figure out, how to build the basic core of your model with, of course, sketches. So intro to sketching is the goal. We're also going to walk through the sketch toolbar, of course. I'm going to try and cover as many of the commands in the sketch toolbar as I can. I'm going to walk through each one of the tools, many of the relations, dimensioning, creating planes. As I go through this, I have a few miscellaneous tips and tricks I like to point out just, at any points through the webinar. So just keep an eye out for those. But that's really the goal with this. Now, there's one last slide that I want to get to before we jump into it, and that is just kind of the basics of sketching. And that is, sketching is a core of what we do in Onshape. So when we're building features, the sketch is the backbone of all of these. And so it's important to understand getting the sketch right is important. Correct design intent, for example, is important. All these things are key. Sketches are defined using a combination of two things, dimensions and constraints. I'm going to walk you through an example of these things in a bit, but it's important to understand there's two elements to getting your sketch defined. It is similar to traditional CAD. So if you've come from a traditional CAD system, there's going to be a lot that carries over to Onshape. So let's walk through it. I want to jump right into things. And as I mentioned before, we're going to start with, the basics, and that is just creating a sketch, simple lines, arcs, and walk through the individual tools. So of course, one of the first things that you're going to need to do, you just started up Onshape and you're ready to start building your first part, is I need to start my first sketch. And so oftentimes the question is, well, I need to start sketching, what do I need to do? And the question is, what plane do you want to start your sketch on? Remember, all sketches are on planar surfaces or faces. So in this case, we have the front, top, and right. So when you create a new document in your Part Studio, you have the front, top, and right planes by default. And so it gives you three options to start your sketch. Now, the question often comes up, does it matter whether I choose the front or the top or the right? And the answer is not particularly. There is one important thing to consider, and that is the front plane will correspond with the front view in your drawing. So oftentimes users like to see the front view of the drawing look a certain way. But 3D modeling, we're going to spin this in all directions. It's not critical whether it's the front, top, or the right plane. So I want to get started. In this case, I want to start on the front plane. So as I move my cursor over the front plane, you notice it highlights. I can left-click the front plane and then select Sketch. Okay. So that's one of the easiest ways to start a sketch. Pre-select the plane. In my case, I just left-click it in the graphics and then select Sketch from the toolbar. So now what I'd like to do is rotate. If you look at the current orientation of the model, if you look at the front plane, I'm not looking straight at it, right? It's at somewhat of an angle. And to rotate that to what we refer to often as normal to the sketch plane, you can do it most commonly with the right click. Now, there's a few things that I'd recommend when you're first getting started. One of the biggest tips for the new user is the right click menu. It has context sensitive options. So if I'm in a sketch, I get exit sketch or copy. Or view normal to the sketch plane. So very important functions in the right click. And it's not just in Sketch. You see right click a feature in the list and you get all these options. So right click menu in general is a very powerful thing in Onshape. Very key thing to point out in the interface. So I left click view normal to sketch plane, and now it rotates so that I'm looking straight at the front plane in this case. So very important, and probably something that just is best to get in the habit of. For starting a sketch is really 3 steps. You select the plane or planar face, you select sketch, and then view normal to sketch plane. Those 3 steps are very common. And so now, of course, I want to start sketching. Now, I'm going to walk you through each of the individual tools here in the toolbar. I think they're, for the most users, I probably don't need to explain what a line or a rectangle is, but more the important details of how to apply them. So the one thing I want to point out is notice now that I'm in a sketch, the toolbar has changed to sketch tools, of course. So I no longer see lofts and all the other feature tools. I see lines, rectangles, circles, arcs, polygons, and so on. So what I'd like to do is walk you through an example of each one of these sketch tools, as many relations as we can get to, and a few other miscellaneous examples that I have as well. Okay, so let's get started sketching. Now, as I move my mouse, I'm going to start, of course, with a simple line. As I move my mouse over a line, you see if I let the cursor stay there for just a few seconds, you get a pop-up box that appears. It says, create a line between 2 points or a chain of lines. And it basically gives you a breakdown of how to create a line. The key thing I want to point out with this is this flyout dialog is for every command. So if I go into corner rectangle, for instance, there's the details to create a corner rectangle or a center point rectangle, right? So it gives you a little bit of feedback as to how to create that particular sketch tool. So that's one of my first tips, is just in general, the tool tips. If you leave your cursor there for a moment, they appear, and it gives you a little bit more feedback about that command. Also notice it says line and then L next to it. The keyboard shortcut for line is L on the keyboard. So important thing to point out, nearly every one of these has a keyboard shortcut. You can access all the keyboard shortcuts from the help menu. So under help, you'll see keyboard shortcuts and a list of all your keyboard shortcuts. Okay, so very important thing, many of these have keyboard shortcuts. As you start to get, more and more into Onshape, keyboard shortcuts become a very powerful thing. You'll see me use them quite a bit in this webinar. So I want to start with a line. I'll select line, left click, and move my cursor down. Notice the cursor changes from an arrow to a crosshair, indicating that you're in a tool. And now I want to draw a simple line. Now, there's actually 2 ways to draw a line. If you've come from a traditional CAD system, this is very similar to those. You can do 2 left clicks or a left click and drag. So I'm going to show you both methods. The first is just simple 2 left clicks. Left click, move the cursor where I want it, and then left click again. Now, The default behavior when you do 2 left clicks is that it assumes that you want to continue drawing another line. So it defaults to drawing another line where you can again left click and create another line. So if you're trying to create a series of lines, that's going to be the method that you choose. But you can also draw a single line with a left click and drag method. So I left click, drag, let go, and it does not default to drawing in another line. So just a tip, you can draw a line 2 different ways, 2 left clicks or a left click drag, and really you get different end results, but the line is of course the same. So that's the first one, of course, the line command. Now a question often comes up, well, I have all this geometry on the screen, how do I get rid of it? You can left click and delete the individual entity, or you can even left drag and window select. And there is a difference between a right to left and a left to right window selection. So again, if you've come from a traditional CAD background, there is a difference in how those two works, and the same applies here in Onshape. But window select and or just single selecting entities allows you to delete. All right, so that's a simple line. The next one I want to move into are, of course, the rectangles in the toolbar. And we have 2 types, corner and center rectangle. And really, you get the same shape. Of course, they're just drawn 2 different ways, and it really depends what type of constraints that I'm trying to apply or what kind of geometry I'm trying to attach this to. So in the case of a corner rectangle, we'll start there, left click. Again, I want to move my mouse down into the graphics where I want to place it. To draw a rectangle, I left click. Move my cursor up, down, left, or right to create the rectangle, and then left click again. And that creates a closed contour, so notice that it shades slightly different color. And so that's drawing a corner rectangle. Very simple. You're just going from corner to corner and generating your rectangle. So very simple. The next one is center point rectangle, and the only real difference here is how the rectangle is defined. So instead of being from corner to corner, it's from the center point and has symmetry. And a useful example of this is like attaching it to the origin, for example. So here, as I move my cursor over the origin, notice it highlights. Left click, and I have a center rectangle. Now another tip is, by default, of course, when I'm in a rectangle and I draw my rectangle in, it assumes that I want to continue drawing rectangles. And to get out of the tool, you can come and select it in the toolbar, or you can use the escape key to get out of the active tool. The thing I want to point out about center rectangle is the symmetry. If I left click and drag, notice that it's centered now over that origin. Right? So I get the symmetry, and you wouldn't get that with a corner rectangle. Okay, so that's center point rectangle. Window select and delete. The next ones in my list are circles. Circles and ellipse. So we have center point circle, 3-point circle, and of course ellipse. We'll start with a simple center point circle. Like the name implies, you start with the center point of the circle. So I'll left click, and if I want to attach this to the origin, for example, move my cursor over the origin, left click, and we have our circle. Okay, so very simple. The main thing with a center point circle, like the name implies, is you define it by the center point. Now the next one is a bit different. It's a 3-point circle, and again, like the name implies, you use 3 points to define the circle. Very useful if you're trying to attach, different various points of the circle to other geometry. So it takes 3 clicks, point, 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 and it defines both the location and the size of the circle. Again, very useful if the goal is to then attach these points to other bits of geometry. Okay, so that is a 3-point circle. Let's move on to the ellipse. I'll select ellipse from the toolbar. Again, we'll attach this to the origin. Now, an ellipse, it's similar to a center point circle in the sense that you start with the center, but there's an additional step to it. So I first start with where I want the center of the ellipse to be. I'll left click, move my cursor. I can move it up, down, left, or right, and it really depends on the type of ellipse that I'm trying to get. So in this case, you'll notice I get the horizontal dotted lines there indicating horizontal ellipse, or if I move my cursor up, you'll see it pop up there the vertical dotted line. So the vertical inference indicating a vertical ellipse. So it depends on what your goal is. In this case, we'll create a horizontal one, move my cursor out, left click, and the one last step is to define the height of the ellipse. Okay, so we'll move it down just a bit. Again, left click, and I have a finished ellipse. So again, pretty straightforward. The main difference is, of course, that additional click to define the height. Okay, moving on. Now we get into some arcs. And the first one I'm going to cover is the three-point arc. And it's very similar to the three-point circle. In fact, it's drawn in a very similar way. But the big difference is, of course, it's not a complete circle. It's just an arc. So 3 clicks, left click, and then left click to set the radius. Right, so the big thing with this is it's very common when, again, you want to attach endpoints, maybe for a arc, transition between contours. So 3-point arc. The next one in the list is the tangent arc. Now the tangent arc, if I just select it and then left click in space, does nothing. And the important thing with a tangent arc to realize is that a tangent arc requires something else to be tangent to. So for my example, let's draw in a line. So we'll draw in a simple line. And then I want to select tangent arc. So we'll select tangent arc. Now you can attach the tangent arc to the end of the line. Again, the key thing with the tangent arc, it has to have something to be tangent to. So I left click, move my mouse up and to the left in this case, left click, and I have my tangent arc. Okay. Now the key thing is the tangent constraint. So if I check show constraints here in the sketch dialog, you'll see it, tangent constraint is automatically created there. So it's automatically tangent with the geometry surrounding it. Okay, so that's tangent arc. The last one is the center point arc. Now the center point arc is very useful when you want to draw an arc and you know exactly where the center point of that arc should be. In the case of a tangent arc, you're starting at the ends. 3-point arcs, you're starting at various outside extremities. But what if I wanted to start an arc by its center? And a common example I give of this, let's draw one more line in, just a simple line, is what if I wanted an arc from all the way from this point to this point? I know the center of that arc is going to be at the center of this line. So what I can use is the center point arc and then move my cursor along this line. And you'll notice as I move it to a certain point, it wakes up that midpoint. You'll see it there, right there. So the cursor changes, indicating you're now at the midpoint of that line. I left click, move up to define the top, left click, and left click. Okay. So 3-point arc, center point arc, the main difference here is you're using 3 clicks to define it, but you're first starting with the center point of the arc. Okay, so let's move on. The next ones in my list are the different polygon tools. Now, we have 2 different polygon tools, but they're really very similar with one difference, and that's how the polygon is defined in size. You can have either an inscribed or a circumscribed polygon, and it's really just how you want to define the size of the polygon. But I'll walk you through both. Let's start with an inscribed polygon. It's very similar to a center point circle in how it's defined. So you first start with the center. So we'll start at the origin, left click, and of course as I start dragging out, you'll see the polygon appear, left click again, and here's the step that's easy to miss. As soon as you left click, you then move your cursor in or out to define the number of sides that the polygon has. So you can go all the way down to a triangle or as many as you'd like out. So just keep in mind you can set as many sides as you'd like. But the key is after you've placed the polygon, so the second click, then you have to move your cursor in or out to define the number of sides, and then left click one last time to place it. Okay, so that's an easy step to miss, especially if you're just getting started with it. Just realize you first have to define the center, then the size, and then move your cursor in or out to define the number of edges on it. Okay, let's move on. Now, I mentioned before, this is an inscribed polygon. The main difference, a circumscribed polygon, the circle is on the outside. So it really just depends how you want to dimension this circle. Is the circle on the inside or the outside of the polygon? We'll do that one more time with a circumscribed polygon again. Left click to locate the center, move your cursor out, left click to define the size, then move it in or out to define the number of lines in the polygon. Okay, so we'll go 6, left click, and we have our polygon. And again, the circumscribed polygon, the only real difference is the construction circle that drives it is on the outside of the polygon and not on the inside. Okay, so the next one is, of course, the spline tool. And if you've come from a traditional CAD system, it's a very common tool for creating very free-form organic shapes. Now, I want to walk you through Spline. There's a lot of details to Spline that I won't be able to get to, necessarily today. But Spline is a great tool if you can't, if it doesn't work with lines or simple arcs or any of the shapes that I've shown you so far. So let's go over Spline. I'll left-click Spline in the toolbar. And initially, when you first start, we'll left-click and then move the cursor. Initially, it looks like a simple line. It isn't until you add the second spline point that you realize that it behaves a bit differently. So if I left-click now, I can bend and manipulate. So it's essentially a free-forming entity. Useful in a number of different situations where you need these types of shapes, and it's not easily created with simple lines, arcs, and rectangles, and so on. But you're really defined by the number of points. So just some tips. With splines in general, the fewer points you have, the better. In many cases, splines are just 2 points or 2 or 3 points. They're not very complex. If I start getting into tons of detail, there's lots of points where I have to adjust to get it just the right way. So in general, especially if you're concerned about curvature or smoothness or any of those kinds of things, the fewer points, the fewer times you left click in the spline, the smoother the shape will be. Some other tips, you'll need to escape out of it once you're done. So once you've finished your last point, or of course you can go back and select it in the toolbar, but it does not, exit. You'll have to exit it. Some other things I like to point out, you can manipulate afterwards. So if I escape out of spline here, you'll see if I left click and drag, I can move these points. And this is what I mean by fine tuning or manipulating the end result. I can grab and drag these spline points around. Splines also have handles on the end, and so I can drag these as well to further change the definition of the spline. So you can grab the end points and drag them. You can grab the actual, ends of the splines and drag them. You can also add more spline points. So if you decide that, this spline needs a point right in here, let's say, I can go back up to the toolbar under spline and add a spline point. So left click, select spline point here, and it adds one more. And now I've got an additional point to manipulate. Splines are very much something that takes a bit of time to get the feel for and understand, but it's definitely an invaluable tool in certain circumstances. All right, so let's move on. Now the next one that I show here is point, and point has a number of great examples that I could give you, but in the case of time, we're going to stick with a simple one. I have a series of some geometry here, and this may not always be absolutely necessary, but I just want to point it out as an option. Let's say, for instance, I wanted to attach something as a reference to the midpoint, or I wanted to attach a point to this line and then reference that for a dimension, some random point for my reference only. That's an example where point comes in, and you can attach points to any sketch geometry, and what it essentially does is just gives you a reference point. You can even snap it to, for instance, the midpoint of this line, and then grab that midpoint and attach it to your origin. There's a number of useful examples I can give you of attaching points, but really just think of them as construction. You have this point that you can reference for dimensions or constraints or whatever it is you're trying to do. So that's the point command. Again, just select point, left click on the sketch entities you want to attach a point to, and then you're off and running. Let's move on to some fun ones, in particular text. Text is a really neat thing. You can actually sketch in a simple rectangle and define text and add it inside of your feature. So let's walk through that. I'll select text from the toolbar. Okay. And then what I'd like to do is just draw a simple rectangle. Now, the rectangle defines where the text is and the size of the text. So you want to be careful about where you place it. In this case, we'll start at the origin and just go up and to the right. Very similar to a corner rectangle. Left click. As soon as you place the rectangle, as soon as you left click that second time, you're going to get a box that pops up asking you for text. What do you want to put in the box, right? So we'll just type in Onshape. We have a number of different font types, so you can choose from a number of different font types. The neat thing about these fonts is it doesn't matter what computer you're in front of, you always have the same list of fonts. And so I hit the green check, and what happens is it fills the rectangle with text. So it's a very simple command. The main thing, though, is the rectangle defines the height of the text, the location of the text, everything. So I can dimension this, I can resize it. So I can grab it and drag it and resize it just by dragging it. I can even delete the horizontal constraint, which we'll go over in just a bit, and move it to an angle. Right? So you can manipulate the text and move it around. The key is manipulating the rectangle that drives it. So that's sketch text. Very simple. Just draw a rectangle, enter it in the text, and it fills that rectangle with the text that you've typed. So let's move on. Now the next one that I have for you takes a bit of time to set up, and that is the use command. And this is from many different CAD systems often referred to as like a convert command. And basically what it does is it takes existing geometry and converts it into the current sketch. So it allows me to take faces or edges or different pieces of already existing features and convert them into my current sketch. And there's a number of reasons this is beneficial. So I want to walk you through a quick example. Now the key thing here is in my case, I need to convert some existing geometry. So just real quickly here, we're going to sketch a simple rectangle. And we're going to sketch a small circle. Okay. And I want to extrude this, so we'll hit extrude, and I'll hit the green check OK. So now we actually have a 3D feature here. A real simple extrude, a block with a hole in it. But what I'd like to do is start a new sketch. And as I mentioned before, you can start a sketch on the default planes, top, front, right, or you can start on any planar face, any flat face. So in this case, we'll start a sketch on this face of the rectangle. I'll select the face, hit sketch, then right-click, view normal to sketch plane. Now what I'd like to do is create an offset of this cylinder and extrude it. So I want a cylindrical boss, but I want to maintain this hole and a small offset of this hole. Now there are two ways to do this, and the new user might actually come in and sketch in 2 new circles and add new dimensions. But a tip is you can constrain or you can add the geometry without having to do that by referencing existing edges. And that's where use comes into play. So I select use, and then I select, in this case, the circle that I want to convert into this sketch. Right? So I selected it. We'll go ahead and left click here. And if I hide the part, you'll notice in this sketch I now have a circle. Okay, so it's converted that circle from the edge of the previous feature. Now, in addition to use, we also have an offset tool that allows you to do a very similar thing, except of course the main difference is instead of referencing an edge and converting it exactly, it does an offset. So I can select offset, then select the entity I want to offset, drag my offset out if I want with the arrow, and as soon as I left click, I enter the offset value. Let's say 1 inch. Okay. So now I've converted the inner circle, I've offset the circle 1 inch, and now I can extrude. Okay. So rather than sketching 2 separate circles and adding 2 different dimensions with all the constraints, I simply convert the previous feature and offset it. Right? And hit the green check OK, and now I've got the cylindrical boss feature I was looking for. And again, I didn't have to sketch any circles. It was just using a convert and offset. Now, there's one big benefit to doing this, and that is design intent. If your goal was to have the diameter the same through both features, then it makes sense to convert it and not add a different dimension. Let me show you why. If you decide later on, let's say months down the road, to change this circle. So I'm going to jump back, and let's say I change the diameter of this inner circle to something bigger like that, right? If I dimensioned it in two different places, I have to now go back to two different places to change the diameter. However, if I use the edge of the model like I did in this example, both features automatically update because one's driven by another. So it's an important thing to point out for design intent, saving yourself time and energy. The use command allows you to convert existing edges, and it adds a layer of design intent that's really powerful. Okay, so moving on, the next things that I want to get into, let's go back to our sketch. Construction geometry. Now, up to this point, everything we've done is what's often referred to as solid lines, right? Solid geometry. However, you can draw geometry strictly for construction purposes, just for mocking up or creating constraints, whatever it is your goal. Now, there's two ways you can do this. You can select the tool that you'd like, so rectangle, circle, for instance, and then select construction from the toolbar. And then when you draw the line in this example, it'll be a construction line. So that's the first method. Select the sketch tool, select construction, and you'll draw a construction entity. Or you can pre-select and then hit construction, and that will convert the entity over to construction geometry. Okay, so there, now this circle is construction. And the main thing with construction geometry, if you're not familiar with the term, is when you go to extrude or revolve, whatever it is, what feature you're creating, it's ignored in that feature. It's just there for your construction. It's just there to aid you, but it's ignored for the purpose of feature creation. All right, so moving on, what I'd like to get into next are a few of my favorite features here, in particular Sketch Fillet. Sketch Fillet's got some neat things that I like to point out, in particular one big tip with left clicking and dragging, but let's just show Sketch Fillet first. So I select Sketch Fillet and I want to essentially radius this corner, right? So I don't want a sharp corner here, I want a radius and a smooth transition between them. I select Sketch Fillet, I select the point, okay, and then I punch in a radius. Okay. So very simple, and all it does in this case is added a 1/2 inch arc instead of that sharp transition. So if all you're trying to do is radius corners in a sketch, Sketch Fillet is a very powerful way to do it. There's one tip that I want to give you though, and that is instead of doing a single click on a point like I did there, what you can do is instead of single clicking, left click drag, and it will allow you to dynamically resize the fillet kind of on the fly. So you can get an idea of what the size is. That looks just about right. Let go. Okay, that's a 5-inch radius. Okay, so it's a great way to kind of eyeball the different fillet sizes and change it kind of on the fly. And again, the main thing there is you left click and drag to get that behavior. By the way, when you do something like this, when I select, for instance, a radius of 5-inch, any more points that I select automatically default in this case to the 1/2 inch value. So I can keep going and adding all these 1/2 inch radiuses. Question that's popped up: can these tutorials be downloaded for viewing later? These tutorials you'll see posted on our YouTube page. So if you're looking for our other webinars, our recordings, we try and post all of them on our YouTube page. So I recommend checking out the Onshape YouTube page. In fact, there's a playlist for webinars. Another question: how do you construct an axis of a hole or a cylinder? Well, let's walk through. Well, give me just a moment and I'll walk you through how I might accomplish that. There's one last thing I wanted to show with this example. I mentioned before the offset tool. So here I have offset. And I showed you before how you can offset a single circle, for example, but you can also offset a whole chain of entities. So if you left click and drag, you'll get an offset of an entire chain. So again, that's another tip that I have. I showed you offset where you just single click and it offsets that entity. But if you left click drag, it offsets the entire chain of entities. How to numerically dimension an object. For example, I want a 3-inch circle. Give me just a moment and I will walk you through dimensions. In fact, we're coming up on it right now. Okay, so the question has come up and I want to get to it before I move on. How do I construct an axis of a hole or a cylinder? And in this case, it would be construction geometry. It's worth pointing out in many cases in Onshape, an axis is, at least coming from a traditional CAD system, isn't always necessary for like things like circular patterns and things like that. It's not necessary. But what you can do if you need a center line going through the middle of a cylinder is construct one. So let's draw a real quick cylinder. And now what I can do is on the right plane, we'll do a new sketch, and I'll draw a construction line, just like I showed you before, line, construction, and you'll see I can attach it right to the center of that cylinder. Okay? Giving you very similar behavior. So if you're looking for a reference for rotation or something to that effect, keep in mind though, this isn't something that you need for like a circular pattern, for example. You can use face references for those. A question, can you offset just a few entities? Absolutely. But that would not be a left click drag. You would be single clicking. So single left click each entity you want to offset. Okay. So that would not be a left click drag, but the other method. Okay, let's move on. Now, the question came up before, what about dimensions? And what about adding dimensions, defining size to all this? So we've done a lot of sketching, but we really don't know what the size of any of this stuff is. So let's just walk you through that. I'm going to start with a simple circle on the origin. And I'm going to draw another circle over here to the right, horizontal to the origin. And then we'll get out of the sketch tool now, or excuse me, the circle tool. Now, I really don't know what the size of these entities are, and if you left click and drag on them, you'll see they dynamically resize. So they really don't have any kind of definition, and in fact, the fact that they're blue indicates that they're underdefined. So when we go later on and add dimensions and constraints, you'll see these turn from blue to black, and in other words, from underdefined to fully defined. So in my case, I want to define the size of this circle. I don't want to know what size that is. The dimension tool, right about here in the toolbar, select dimension, then select, in this case, the circle, move my cursor out to where I want to place the dimension, and left click again. Then just select or enter a value. Okay. So I typed in 1. Notice that it scales the entire sketch to match that, so this circle also changed size to match that. The main idea there is you don't have geometry overlapping or wrapping on itself because of a first dimension change. A question that's come up, is it possible to enter a dimension as a relationship to another dimension? In other words, one side of an object is 2/3 of another side. It is possible through the use of variables, which is something we're not going to get into at this level, but I would recommend, we have videos on variables. What you would do is you'd create a variable for the object and then set an equation to drive, that variable times 0.66 or whatever the equation, whatever the math would be. But you can do math inside of the dialog here. So simple math, if I go in, it would be like 3/4. And of course that solves to 0.75. You can do basic math, but referencing another object, another edge or dimension requires a variable. And that's the important thing to point out. It's something I won't have time to get to here today, but worth checking out if that's your goal. Can you select the outside of the cylinder to make an axis? No, but I will say that in many cases an axis is not necessary. So I'm not sure. I mean, maybe there's a scenario where you're referencing it for a dimension and things like that, but it's not used. If you've come from SolidWorks, for example, an axis is used for circular patterns and all kinds of sketch reference entities. That's not the case in Onshape. In many cases, you don't need that because of the snaps and things like that. But no, and in fact, there is no quote-unquote axis functionality in Onshape. What I showed you a moment ago was actually construction lines. Okay, so let's move on. There are a few neat things I wanted to point out. Dimensions are an important one, so it's important to spend some time on them. They are very simple. It's I select the entity, I place the dimension. One thing I want to point out though is there are a few differences between this and traditional CAD systems. For example, I want to dimension from the outside of the arc to the outside of the arc, and oftentimes this is an option or a keyboard shortcut. And Onshape, if you just select outside of the arc, it knows that you want dimensions from the outside points and not the center points, right? Now, if I wanted dimensions from center points, I would just select center point, and then place my dimension. Okay, so it's a bit of a different process, but just keep in mind it's a bit more intuitive. Select the outside of the arc, and I get an overall dimension. Punch in a value. Okay. Now, what I want to point out is the level of definition that I have here. Notice that the right circle is not defined, but the left circle is, and you get the visual feedback. This is black. This is, of course, blue. Another way to test this is just to grab and pull. You'll notice that the length is defined, but the diameter of the circle is not defined. Right. So we'll dimension that just like we did the one on the left. Left click, and we'll make this 0.75. And to edit a dimension, for instance, this 3.3, I want to change that. I double click the dimension and I can change it. So now my sketch has gone from completely blue and essentially free floating in space to constrained with dimensions and constraints. Now, we haven't gotten into constraints yet, and that's something I want to cover right now. But I want to point out that many of the constraints are automatically created. So there's the concept of snaps in many traditional CAD systems, and Onshape has a very similar thing. A lot of the creation of constraints is automated just by these snaps. So if I check Show Constraints here in the checkbox, or excuse me, in the sketch dialog, you'll see all the various constraints that were automatically created. So I've got distance constraints, horizontal constraints between the two center points, a coincident constraint attached to the origin. And if you're new to this, just know that a lot of this is automatic. You don't have to worry about it causing issues or anything like that. What I will point out is there will be scenarios where you need to manage these. You'll need to go in and select a constraint and hit delete key to delete it, or you'll need to go in and manually add a constraint, which I'll show you in a second. A point that's been brought up, can you specify a dimension as a reference dimension? What I will say about dimensions as references is they automatically become references. So for instance, I've fully defined this sketch. There's no need to add any more dimensions to it. It's fully defined. If I add another dimension, it automatically becomes a reference dimension. So you will not get that scenario where adding 2 dimensions will over-define your sketch. It's just one turns to a reference dimension once it's fully defined. Okay. So yes, we can do reference dimensions. You can place as many as you like, and they don't over-define in the usual sense. They just automatically become references. All right, so let's get into some simple line creation. Now, what I'd like to do is, of course, draw lines that join these 2 circles, but what I'd like to show you here is the idea of the constraints and how they can automatically be added and they can be manually added. So let's walk through it. I'll select a line from the toolbar. And then what I'd like to do is draw a line that joins this circle to this circle. So of course I want the start point attached to this circle. If I move my cursor over it, notice it highlights. So it's giving me that visual cue that you're attaching your line to this circle. Left click, move my cursor down. Okay, notice again it highlights. So now I'm attaching a coincident. If I move my cursor to just the right position, I get both coincident and tangent. So you can get 2 constraints created in one shot. Left click, and now I have my line in place. some things I want to point out. I created one line with 2 clicks and 3 different constraints automatically. So when I say before, many of the constraints you're not going to have to create yourself, this is what I mean. You can use a lot of the snaps and behavior of Onshape to automatically create them. Here's coincident, tangent, and coincident. Okay, we'll do that one more time to the bottom half. Okay, again, you want to wait for that visual cue. There we go. And now I have an enclosed contour. However, it's not fully defined. Okay, notice that these lines are blue. If I left click and drag, okay, I can see that this line is not tangent with this circle. So this is an example where I need to manually add a constraint. Okay, so in these situations, no matter what the constraint type is, all you do is select the entities you want to constrain and your constraint type. So for example, I want to make this line tangent with this circle. I left click both. There's no need to hold control or shift or any of those things. Just left click each and then select tangent. Okay. So again, and it doesn't matter what kind of constraint it is. Select the entities, select the constraint type. We'll do that one more time. Left click, tangent. Notice now both lines are black. The shape is again fully defined. Now a tip is sometimes these constraints can get overwhelming. In fact, pretty quickly they can be, to have them on all the time. So turning them back off is advised. But what that means is if I want to look at the constraints for an individual feature or line, geometry, whatever it is, I have to mouse over it. So I move my cursor over that entity and you'll see them wake up and then I can select them. And by the way, if you've added a constraint that you don't want, you can left click and delete with the delete key on the keyboard. And that will remove the constraint. All right, so one last thing I want to do, we're going to add 2 more circles. Now, I want to deliberately draw these circles off of their position. Now, you wouldn't, and I realize that, but just for the educational purpose, I'm going to deliberately place these circles kind of out here in random space. Okay. And of course, what I want these circles centered inside of this circle. That's the goal with this, and there's a few ways you can accomplish this. What I'd like to show you is the concentric constraint. And again, I select the entities, I select the constraint type. So I want this circle concentric with this circle, left click the 2, select concentric. Right? So now this circle is centered inside of this one. Right? Diameter is not defined, but it is centered inside of it. One more time, left click, concentric. Okay, and now the 2 circles are centered. And again, I stress that the process is really the same no matter what constraint that you're creating. Select the entity, select the constraint type. Now another example, let's say for example I wanted these 2 circles to be the same diameter. I could of course add a dimension and dimension them both separately, but a bit more design intent would be to create an equal constraint between them. So again, left click, set them to equal. Okay. Now, when you change the size of one, they both update. Okay. So just a bit more design intent, but the main thing I want to point out with constraints is that you select the entities, select the constraint type. That's really all it boils down to. I don't necessarily have time to go through an example of each one. I do have a few more things I want to show you here. Okay, so let me jump out of this real quickly here. What I'd like to show you next is an example of sketch image. Okay. Sketch image is a really neat tool that allows you to bring in a picture from anywhere, anywhere you can get it, and use it as a reference for your sketch. Okay. So here, if I zoom in here, you'll see I've modeled this bike frame up, and I've imported an image of the pedal for it. Right? Really useful if you're trying to use as a reference for whatever sketch entity you're trying to create. So let me walk you through this process. We'll go ahead and delete that sketch. It's important to point out the first step in this, you must import the image into the document. Right? So you'll see here on the far right I have pedal PNG. On the bottom left corner you have this option to import. You'll need to import the image first into the document. Bitmap, JPEG, PNG, all supported. Many of the common file formats are supported. So once you've imported the image into your document, you can add it to a sketch. And the way that works is, of course, in the sketch tool. So I'll start a sketch here. Under this insert, you'll see a little insert drop down. We have insert DXF and insert image. So we can insert DXFs into sketches, and we can also insert images. Right? So I select insert image. What happens is you get a prompt to select the image from the document. Remember, you could have multiple images here. So I'll select the petal. And then, much like sketch text that I was showing you earlier, you just draw a rectangle. Okay. The rectangle defines the image's location, the image's size. You can constrain the rectangle like it's a normal rectangle. So it's a great way to get the petal, in this case, exactly where I wanted it. I could come in here and add, some kind of a midpoint along this line, and then move that midpoint and attach it to some other sketch entity. So it's a valuable way to go in and constrain it very easily, without a lot of energy. And the nice thing about this, you could just use it as a simple way to import like a decal, for example, or you can use it as a tool for you to then go in and maybe I can start to trace the outside geometry of this using a spline. Okay, so very neat tool. Something I always like to point out, if you have a picture of something you're trying to reference for your model, or maybe you're just trying to build a simple shape for reference, sketch image is a great way to do it. You're going to spend some time going through and tracing the geometry, but it's a great reference to have. Okay, so let's move on. One of the last tips that I have for you today is the copy sketch and copy sketch entities, and for that we can jump back to our original tab here. And what I'd like to do is walk you through a simple copy sketch. Let's go back. Actually, let's just delete. I'm going to create a very, very simple sketch here of an ellipse. Okay. So I've already shown you an ellipse. Again, 3 clicks to define your ellipse. But let's just say that I need several ellipses in several different planes in different locations. And of course, you can go in and sketch individual sketches. But what you can also do is create what we call copied sketches. You can copy sketches and paste them onto different sketch planes. Now, another thing that this somewhat ties into that I mentioned before is custom planes. So there will be situations where you don't have a planar face or a flat face or a default plane. You really don't have either of those don't work for you, and you need your own custom plane. That's where construction planes come into play. So in my case, what I'd like to do is I'd like to insert a copy of this ellipse 3 inches in front of it, where it's currently at. So I need to insert a plane 3 inches in front of the current front plane, and then copy my sketch to that. This is a very common workflow if you've built lots of lofts, for example, in traditional CAD systems, where you have several planes and variations of the sketch entities to loft between. So I select plane, and we have a number of different plane types. So if I'm looking for instance, I want it normal to the end of a curve, that's a curve point. I can have 3 different points to define a plane, or plane point. Plane and another point as a reference. So there's lots of different examples I can give you for plane types. Mid-plane is another very common one between 2 planar surfaces or planar faces. But in my case, I just want a simple offset. So I want an offset plane 3 inches in front of the front plane. So I'll select the front plane in the graphics, and there is my plane. You'll see it put out here on the right. Now, if I want it flipped around, I can hit reverse direction, and you'll notice now it's over here on the left. So again, the main thing here is I'm building myself a reference for further sketching. So I can hit the green check OK. Notice plane 1 has been added to my feature list, and I can start sketching on that plane. So just an important thing to point out, you can create sketch planes for references, and you will need to for the more complex models that you create, and we have lots of different ways to do them. A question that's come up: how do you create a plane on the surface of a cylinder at an angle? There's a few ways I might try to do this. I think that in my case, I might even model up construction geometry just for the point of doing a curve point at the end of it. We don't have a way to reference the radius of a face and say tangent to that. Yeah, I might actually create a construction line, for example, and use that as a reference, and then use curve point to define it, where I'm just selecting the line and the end point, and it creates a plane normal to that. Yeah, there may be a faster way. That's just off the top of my head. Forgive me. Okay, so what I'd like to do is show you the copy sketch, and there's a few things that I want to point out here. It's more than just copy sketch. You can also copy individual sketch entities. So if I had a sketch that consisted of many different things, but I only wanted to copy a small piece of it, you can do that also. And I'll show you that in just a second. But let's start with copy sketch. Now, copy sketch, really simple. You right-click the sketch in the feature list. You choose copy sketch. Then you right-click the plane or face that you want to put it on, and go to paste sketch. Okay, it's important to point out, it's a very commonly asked question, these two are not linked. So if I change one, the other does not. And you can do that. You can accomplish that with a derived feature, but it's a little bit different. All right, so it's a different workflow, maybe a more advanced topic to discuss. But it's important to point out when you do a copy sketch like this and paste, it is not linked to the original. What that also means is now I can come in here and make this one bigger and create a very similar, ellipse with a slightly different contour, right? So copy sketch and paste sketch, both in the right-click menu. You can do them from the graphics or from the feature list. I mentioned before, you can also copy sketch entities. So if I'm in a sketch, I can right-click an individual sketch entity, and you'll see copy sketch entities. So maybe you've got lots of lines and arcs and rectangles and things in this one sketch, but you only want to copy a piece of it. That's copy sketch entities, and then you can paste sketch entities. Okay. So that's copy and paste sketching. That's really what I had planned for you here today. There are a few last slides that I have, so if you want to bear with me for just one more moment. I mentioned before that the sketch logic is a bit different. It's important to point out with Onshape, we don't have to worry about trimming as much, especially if you've come from a lot of traditional CADs where you have to have one enclosed contour. With Onshape, you can extrude any piece of a contour or the entire contour, and it's entirely up to you. So overlapping contours are okay. I wouldn't worry too much about trimming to clean things up. If it helps you, that's fine, but it isn't necessary for Onshape to work. We automatically choose which contours to extrude. It doesn't mean you have to use them. You can choose any contours you like, but realize that even though you may have many overlapping contours, we're fairly intelligent about choosing which one's the correct one. So the logic behind it. The question often comes up, well, let me jump back just real quickly here. If I have this sketch, let's say, and I have, let me go back to my previous example here. If I have a circle and some lines that overlap, forgive me for doing this hastily here. So I've got all these overlapping contours. I don't need to worry about trimming all these pieces out. What I can do is extrude. You'll see it automatically chooses the entire contour in this case, but I can X out of it and choose individual pieces of it. So I can extrude several parts at once or any individual contour within the sketch. So again, you don't have to be overly concerned about trimming entities. If you like the cleanliness of it, it's fine, but it's not necessary for Onshape to work. So just a quick note on the Extrude Logic. Planes, I showed you briefly planes. We don't have a ton of time to get into planes. There's more complex examples I can give you, and maybe a whole nother topic to itself. But planes are key, and I've shown you how to create basic construction planes. At some point, if your models get more complex, you will need construction planes, and definitely something to check out and spend a bit of time on. There's a number of examples I can give you. I've shown you just briefly some of them. So that's really what I had planned. I want to say thank you, everyone, for coming. I'm going to stick around and answer any questions that you have, so feel free to type them in. But yeah, that's it. Thank you, everyone.